In today's video, I would like to introduce a very nice problem of Australian Mathematical Olympiad edition 2020. Here is the following information. Determine all pairs A and B non-negative integers. What I mean with non-negative integers, it's mean the positive integers including 0, okay? So such that we have this following equation. We have the sum of these terms A plus B is divided by 2 minus the square root of this product AB equals 1. If you take a look at this expression, we have a nice symmetry here. Whatever happens with A, it will be the same with B, okay? Because we have the sum here and then we have the product here. I would be recommend to give the try to this problem pre-rigor into the solution. So go ahead, pause this video when you are come back to see the full solution. Now let's get into the solution. Without loss of generality, we have A, B is a solution, and also we have B and A is a solution, okay? Let's assume A is super equal to B. It's enough to go over this direction. So once you find the solution, you will be included the other one. First of all, I'm going to check the obvious cases, okay? We are going to check we have equality or no. If A equals B, I'm going to insert this one into the setup. I will have 2A over 2 minus square root of A squared. As we know, A as a positive integers, we'll have A minus A, which is 0, which is not verifying our equation, okay? Which means A is strictly superior than B. Now I'm going to check the obvious cases. If A equals 1 and B equals 0, always go in this order because we have A strictly superior than B. So now I'm going to plug this information into the setup to see what's giving us. I will have 1 plus 0 over 2 minus square root of 0, which equals half, which is different than 1, which is not verifying our setup as well. So let's check if A equals 2 and B equals 1. I'm going to do the same thing. I'm going to plug this information into this our original equation. I will have 2 over 2 plus 1 over 2 minus square root of 2. I will have 3 over 2 minus square root of 2, which is different than 1, which is also not verifying our setup. Now I'm going to do the general case now. If we have A is strictly superior than B, with A is super equal to 2, with A is super equal to 3 and B is superior equal to 2, like this, okay? Now I'm going to work on this condition now. Now I'm going to take this condition at the top and continue solving our equation. Now we were ready to solve our equation. So I have this expression A plus B over 2 minus square root of A is multiplied by B equals 1. I'm going to simplify this expression by multiplying both sides by 2. I will get A plus B minus 2 square root of A B equals number 2, okay? If you take a look carefully at this expression, this one is the same as square root of A minus square root of B quaternary square equals 2, okay? So if you distribute this one is taking us back to this one, okay? So now I'm going to apply the square root on both sides, since we have these terms are positive because this term is bigger than this term. So I'm going to apply the square root on both sides. I will have square root of A minus square root of B equals square root of 2. In fact, we have two cases. We have plus or minus square root of 2. Since you have this term is positive because square root of A is bigger than square root of B, that means we are going to take only the positive case, okay? Now I'm going to move over this square root of B to the right. I will get square root of A equals square root of 2 plus square root of B, okay? Now I'm going to raise number 2 as a power on both sides. I will have the following expression. I will have A equals 2 plus B plus 2 times square root of 2B, like this, okay? Then I'm going to move over these two terms to the left. I will get a minus b minus 2 equals to square root of 2b. Okay, so since the left hand side of this equation is an integer, that's mean the right hand side of this equation is an integer as well, which means I'm going to note this one as a k, as a positive integer number. Okay, one is telling us. Then I'm going to square both sides, this one and this one. I will have 8b equals k square. Okay, notice b is super equal to 2 always. If b is super equal to 2, which means if I'm going to replace number 2 here as a minimum value, I will have 8 is multiplied by 2, which is 16. I mean, that's mean k square equals 16 as a minimum value can take. Okay, which means if I'm going to take the square root on both sides, I will get k equals 4, which means k is a multiple of 4. Okay, it's equivalent, k is congruent to 0 mod 4. Equivalent, k equals 4 is multiplied by n, because k is a multiple of 4, whereas the n is a some positive integers. Okay, then I'm going to square both sides. I will get 16n square equals k square. As we know, k square equals 8b. Okay, and I'm going to take the square root on both sides. I will have 2 square root of 2b equals 4n. Okay, then I'm going to divide both sides by 2 square root of 2. I will get square root of b here equals 2n over square root of 2. 2 will be cancelled out. So this one, 2 over square root of 2 is the same as square root of 2 is multiplied by n, like this. Then I found the value of square root of b. I'm going to take this value and insert it into this equation. So I will have square root of a minus square root of 2 n equals square root of 2. Then I'm going to move over square root of 2n to the right. I will get square root of a equals square root of 2 plus square root of 2n. Then I'm going to take square root of 2 as a common multiplier. I will get square root of 2 here is multiplied by 1 plus n. Okay, then I'm going to square both sides. I will get a equals 2 is multiplied by 1 plus n quinary square, like this. So I have ended with this expression. Now we found the value of a as a solution. So I'm simply going to find b, because b equals to this one. For b, I'm simply going to square this term. I will have b equals to n square. Okay, now we have ended with these two solutions. Now I have two following solutions. I will have a equals to is multiplied by 1 plus n square, and b equals to n square. And by the symmetry, we are going to write another pair of the solution, which is a equals to n square, and b equals to is multiplied by 1 plus n quinary square. Okay, so I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.